We all know and understand how hot air rises. Anyone who has put their hand on a cold glass of water has felt the cold air flowing down the sides too. That is because given the same volume of air, the cold air is going to be more dense and way more. So what's the missing piece? Humidity. Water weighs a lot. Actually, 1 gallon of water weighs 8 pounds. Warm air can absorb a lots of water too. Every time you hear or see anything about a tornado, you always hear about warm, moist air from the Gulf. Just because warm air has absorbed the water doesn't mean that the water has disappeared. It is still there and adds weight to the air. That is how warm air becomes heavier than the cold air. Let's go back to this example of how cold air is heavier than the warm air. Well, that is at the same humidity. I have no idea exactly how much the air weighs and at what humidity. These are only figures for illustration purposes. Now let's add some water humidity to the warm air. There will be some point where the higher humidity level in the warm air will equal the same weight or density of the cold air. At what point this happens, I don't know exactly. Again, this is only for illustration purposes. Then again, add some more water and there will be a point where the warm air will be heavier than the cold air. Why is this important, you ask? Well, because of this. Warm, moist air from the Gulf flows up to the colder air of the north. Most times the warm air should flow up over the top of the cold air, forming clouds at the layer where the two meet. The water in the warm air condenses to form clouds, and if enough humidity exists, it eventually rains. But sometimes when the warm, moist air is heavier than the cold air, remember that's an important part that I talked about a few seconds ago, the cold northern air slides up over the top of the warm, moist air. That cold air is now on top of the warm air. It is heavy and will start to compress the warm air, not only slightly heating the warm air, but raising the humidity level too, further spilling more cold air on the top of it. This is the reason why predicting tornadoes is going to be really difficult. Conditions for this are going to have to be just right for a tornado to happen. As more cold air spills over the top, a higher pressure point forms, further pressing down on the warm air into a bowl shape. Clouds will form at a boundary layer between the warm air and the cold air, like this. When the heavier cold air on top compresses the warm moist air on bottom to a magical tipping point to where the humidity level reaches 100%, the water in the warm moist air will start to precipitate out in the form of rain. The warm air, now with less humidity, is less dense than the cold air on top of it, and both now need to change places. The heavier cold air now pushing down through the trapped warm air forms a cone shape like this, with the cold air in the center flowing down and with the warm, less moist air flowing up around the outside. This will continue until all the trapped cold air on top changes place with the warm air on the bottom. There's really no way to tell how much cold air is trapped on top. The more trapped cold air on top, and the greater the humidity difference between the warm air and the cold air, will determine the size of the tornado. To my knowledge right now, there is no way to measure humidity differences in the air or even tell the temperature differences at different layers unless there's already rain droplets in the air. Until that happens, predicting tornadoes will only be a guessing game. Oh, and you're welcome, Weather Channel.